Welcome back. So here we'll be discussing about the part two of these this section about inverse function. So we talked about one-to-one function earlier. So here we'll talk about what is the importance of one-to-one function. Now, if a function is one-to-one, then we are sure that its inverse will be well defined. It means the inverse will make sense. Now, what do I mean by that? Just to show you this example, we discussed this example earlier. And if you look at this function, this one, we said is not one-to-one. If you remember, because we have g, as you can see, g of what? G of 3 is the same thing as what? G of 2. And it all equals to 4, right? So let's call this is g, this is f. So you see this one, you have g of 3 goes to 4, g of 2 also goes to 4, right? But we can see that 3 is not equals to 2. So we concluded in the first part of this video that g is not what? Is not one-to-one. Now, so because g is not one-to-one, let's try to find its inverse. What is its inverse? The inverse of g will just be going from where? It will be going from G to, now it will be going from B to A, right? Because G is going from where? From A to B, as you can see. So what is B? B here, the first thing here is 10. Then we have 4. Then we have 2, right? Why A? What are the elements in A? We have 4, 3, 2, and 1. So you see that 10 is mapped to what? To 4. Because, you know, when you go this way, it's G. When you come back, this is G inverse. So 4 is going to map to what? 4 is going to map to 2 elements. 4 is mapping to 3. At the same time, 4 is mapping to 2. Then finally, we have what? 1 mapping to 2, which is the same thing as 2 mapping to 1. So this is the G inverse. And you will agree with me that this is not a function. This is not a function. Why? Because you have G of 4, because G inverse of 4 is mapping to 2 elements. So you see G inverse of 4 is the same thing as what? 3. And at the same time, G inverse of 4 is the same thing as what? 2. So this is not a function. So why is this G inverse not a function? It's simply because the G itself is not one-to-one. So whenever G is not one-to-one, then you cannot talk about the inverse. The inverse will not be a function. But if you look at f, you see this f is one-to-one because every element of x have a different value of y. Now let's try to get the inverse. The inverse is going to be from b to a, right? So starting from 10, 7, 4, 2. So you can see that 10 will give to 4. 7 is mapped toward 3. 4 is mapped toward 2. And 2 is mapped toward 1. So this is our f inverse. And this is a good function. It's a well-defined function. And that is simply because f is originally 1-to-1. So anytime you have a function to be 1-to-1, then you can talk about the inverse. Okay, now let me just explain this here. So if you look at this now, this is A. A means the domain, right? And let D be the range. So if you have an element X here, F will take X into what? Y. So it means that Y, if the inverse is the reverse, you go from B to A. So it means that if you have f of x is equals to y, if you go the reverse, you will have f inverse. What will be the input here? Because the arrow goes from right to left, is going to be f inverse of y equals to what? It gives you back the x in the domain. So what simply means is, it means we can come up with this relationship. If you have f inverse of y equals to x, it simply what? It simply means that f of x is equals to y. Right. So, and one thing we can establish from here is that what? If you look at from here, you see what is the domain of f? The domain of f is what? The domain of f means the value of x. The input of x of f is a. So the domain of f is a, but the range of f is what? The y values is b. We can see that. Now, but when you are talking about inverse, inverse now is going from left to where? From right to left. You are going this way. So the inverse, the domain of f inverse is going to be b, right? Why the range of f inverse? Because f inverse is taken from b and is taken from b to a, right? Because it's coming left to the right to left. So the range of f inverse is equals to what? Is equals to a. So with this, we can establish something, that the domain of f inverse is the same thing as the range of what? Of f. And in this case is equals to b. This is what we're talking about here. As you can see here, this is the domain b. The b's are the same. And what is that? It means the domain of f inverse is the range of f. And another thing we can also see is that the range of what? Of f inverse is equals to what? The domain of what? Of f. And what is that? That is simply equals to a. So we have it here. Let me use the green here. So a. All right. So this is established now. Then let's go and see how these things work. Apply. We can apply them. So here we have b. So this is equals to a. Right? Now let's see example 2 here. What is this example asking for? It's saying that we should just find the what? You are given f1, f of 1 is equals to 5. So if f of 1 is equals to 5, f of 3 is equals to 7, f of 8 is this, so we just need to find these values. So if we're given that f of 1 is equals to 5, and remember we established something. We said if you have f of minus y, f inverse, if you have f inverse of y equals to x, this simply means that f of x is equals to y, right? So it means that if you have f of 1 is equals to 5, so this is like our x here, this is x, and this is what? This is y. So it means you have this part. So this simply means if you are using this part, so you need this part now. So this means that f inverse of y, what is y? 5 is just equals to 1. So for the second one, we have f of 8 equals to minus 10. No, I think this is the third one. So let's do this one first. F of 3 is equals to 7. This will simply imply that f inverse of 7 is equals to 3. And finally, f of what? 8, f of 8 is equals to 10, implies that f inverse of 10 is equals to 8. All right. Now, example 3. For example 3 is that we're given what? We're given the graph of f, and we want to deduce these values from the graph of f. So we want to deduce what is f inverse of 2, what is f inverse of what? Of 5, and what is f inverse of 6. So how do we do this? Now, let's start with this one. So A, if we have f inverse of what? Of 2. So definitely, since f inverse, it means this is our y, right? Because f inverse, the input of f inverse is the values coming from the range of f. So let's say this is equals to x. We don't know what x is. So it means if we know what is x, we know we have our answer, right? Then if f inverse of 2 is equals to x, what does this mean? This simply means that what? F of x is going to be what? Is going to be 2. Why? Because we're just using what we discussed here, this relationship here, this one here, which we wrote here. If f inverse of y is x, it means f of x is equals to y. So if f inverse of 2 is equals to x, it means f of x is equals to 2. So all we need to do now is we go to graph, and we go to the graph and see which value of x will give us f of x is equals to 2. So if this is our graph of f, you can see we need y to be 2. So we need here, this is 2, right? So it means we are here somehow. So you just trace from 2 to touch the curve, and you go down and you take the x value. So it means x is going to be what? Is going to be 6, because if this is 4, this is 5, this is 6. So you can see that f of 6 is equals to 2, right? So it means that that x we're looking for is our inverse, because we set f inverse to be equals to x. So we can conclude that f inverse of x is equals to what? Not f inverse of x, but f inverse of 2 is going to be 6. Okay, let me do the same thing here again. So if you're looking for f of inverse of 5, just say it's equals to x. So it means if you can find what is x, you find what is your f inverse. But this means that what? This means that f of x is equals to 5. So all you need to do is go to 5. Where is 5? Because 5 is the y value. This is 4, this is 5 here. And just go to the line. Go to the touch the curve. And then go down and take the x value. So what is the x value here? X is 2. So you can see that f of 2 is actually 5. So it means that x is equals to 2. So what that means is you can conclude that what? F inverse of what? Of 5 is actually equals to 2. Then let's do this last one, which is the C. Now for the C, what we have here is F inverse of what? F inverse of 6. The same story. So we have F inverse of 6 equals to what? X. And this will mean that f of x is equals to what? Is equals to 6. So if f of x is equals to 6, so you just need to go to 6. Where is 6? This is 5, this is 6. 6 is somewhere here. And what will be the value of x? You just trace down. Definitely is at where? At 0. So it means that x is equals to 0 because f of 0 is equals to 6. So your x is actually 0. And that x is your f prime of f inverse. Did I say f prime? No, f inverse. So f inverse of what? Of 6 is equals to 0. All right. Okay, so the next one is what we call the cancellation property of inverse function. The cancellation property of inverse function. So here, what do we do here? This, anytime you have a function to be one-to-one, then this cancellation property is true between the function and its inverse. So it means if you compose, this is like composition. So f inverse compose f is going to give you just x. And f compose f inverse is also giving, just to give you what? Just x. So this is to tell you that what? The inverse function f inverse satisfy the following cancellation property. So it means, we call it cancellation property. It means the function and its inverse, they cancel each other. So f inverse is like f inverse canceling f. So you are left with x. Not just from the left, also, if you have f and f inverse, they also cancel. You have x. So these properties indicate that f is the inverse function of f inverse. So we say that f and f inverse are inverses of what? Each other. So let's see this example here. It says, show that f of x equals to x to power 3 and g of x, x to power 1 over 3 are inverses of each other. So all you need to do now is we need to show two things. We need to show one, we need to show that f of g of x will be what? Will be x. And we need to show that the second one, also g of f of x, should also be what? Be x. If we can achieve this, then we are sure we can conclude that what? F and g are inverses of each other. So let's try to achieve the first one. Let's see. What is f compose g of x? It's just f of, what is g of x? Is x to power 1 over 3. And what is f of this? F of this is what? Is x cubed to power 1 over 3. Because this is f, which is x cubed. And this is equals to what? This is definitely equals to x. Let me explain this again. This is f of, what is g of x? G of x is x to power 1 over 3. And now you need f of this. But what is f? What does f do? What does it do to its inputs? It will just take the power 3. So that is why we add, okay, no, this is not this way. Yeah, good. So this will be x 1 over 3, then all to power what? 3, which is still going to be x. Now, the second one is g of f of x. And what do we have here? In that case, you have g outside. You have f of x inside. What is f of x? Which is x cubed. So now the outer function, which is g, what is g? The output will be raised to power 1 over 3. So this will be x to power 3, then 1 over 3. And this will still give us what? Will still give us x. So the two properties are satisfied. So we can conclude that what? F and g are what? Inverses of what? Of each other. Are inverses of each other. All right. So in our next video, we'll be looking at how to find the inverse of what? Of functions. How to find the inverse of function. Thank you for watching. If you have any question, just put it in the comment section.